Hi, welcome to Orozco's Lectures. I am Jose Orozco, and these are my lectures. This lecture is a pre-calculus lecture. I hope you enjoy it. This is chapter 1.7, which is on transformations of functions. All right, and we're going to start first by talking about vertical and horizontal shifts. Right. These are also called translations. All right. The vertical and the horizontal shifts. But let's see. Let C be greater than 0. And let f of x be some function. So be a function. All right. Now, first, if h of x is equal to f of x plus c, then this is a vertical shift upwards by c units. All right. Now, so if we do a plus c on the outside, it's a vertical shift upwards. I'm just going to copy and paste this here, and we're just going to manipulate this. The second one is if h of x is equal to f of x minus c, this is going to be a vertical shift downwards by c units. All right. Next one, if I've got h of x being equal to f of x plus c, that plus on the inside, this is going to be a horizontal shift to the left, all right, by c units. All right, here anytime we do something that's horizontal, it's going to kind of do the opposite of what we think. All right, so here with this plus, it's still being moved to the left. And lastly, again, we're just going to manipulate that statement for the fourth. H of x being equal to f of x minus c. There we go, f of x minus c. It's a horizontal shift to the right by c units. All right. So again, vertical shift with a plus on the outside, it's upwards by c units. If you take the function f of x with a minus on the outside, it's down. Plus on the inside, it's to the left. And minus on the inside, it's to the right. All right. So what does that mean? Let's just get some generic idea. All right. So let's say that this is some function. My original function here, I'll draw in blue. Some function. All right. This is f of x. In case 1, which I'll do in yellow, we're moving upwards by c units. So something like this. All right, where this right here is c units. This right here is f of x plus c. All right. This second scenario, which I'll do in pink, purple, I think one of those, I don't know. We'll draw it this way. All right, f of x minus c. It moves vertically downwards by c units. So this is f of x minus c. And that distance there is also c units. All right. Similarly, so that's the first two scenarios. Let's look at how it looks horizontally. So again, I'm going to start by drawing my function f of x here. Right, this is in blue, this is f of x. And again, I start with yellow here. For this horizontal shift to the left, where we have the x plus c, well, it's going to move to the left by c units. All right, so this right here is c units, and this is in this yellow f of x plus c. And again. Maybe it's magenta, I have no idea. There we go. So that's going to be C units, right? With the f of x minus C, that minus on the inside moves to the right by C units. So this is f of x minus C, all right? So in here, we can also describe the transformations by what happened to the point, right? So for example, in here, with this vertical shift upwards, we can say that each point x comma y from, perhaps I'll do that one in blue. Each point x comma y goes through the transformation to the point x comma y plus c, right? Because everything's being shifted upwards there. And similarly, the point x comma y goes through the transformation and it goes to the point the other one as x comma y minus c, all right? Each one of these points to there. Similarly over here, with the horizontal transformations, we can say that the original point x comma y on f of x goes through the transformation and it ends up going to, for this one, x minus c comma y, right? So the point 0, 0, for example, here would go to negative 2, 0, all right? And similarly, for the purple one, we would say that the point x comma y goes through the transformation and it ends up at the point x plus c comma y. So now let's do some examples. So let's say that I said use f of x equals to x cubed to sketch. Use f of x equals x cubed to sketch. And here we go. Example A is going to be h of x is equal to x cubed minus 5. X cubed minus 5. All right. So in here, well, let's see what this would look like. First, I'm going to go ahead and sketch f of x. All right. So in here, f of x being x cubed, it looks something like this, right? That's f of x. And in here, our h of x is x cubed minus 5. So simply go down by 5 units. Let's say that that's 5 units. All right. And in here, we're going to get, well, pretty much copy the same exact thing. All right. What we're doing is shifting downwards. And this right here is h of x. All right. Going down by 5 units. Now, let's do another example. Let's say that I have g of x being equal to x plus 3 cubed, and then that plus 2. All right. In here, x plus 3 cubed. Well, let's see what's actually going on there. We're going to be shifting this to the left by 3 units and upwards by 2 units. So this point right here, our original function, because it's cubic, right? To the left by 3 units and upwards 2 units. So we're going to end up with this point over here. And from there, redraw the function. So there we go. And that's what that would look like. All right. And this right here would be g of x. And again, this transformation over here was just strictly down by 5. All right, so that's the vertical and the horizontal shifts. So let's talk about reflections in the axis. So reflections over the axis. All right, so we're going to start by, let's let f of x be a function. Then we get the following. All right, we get the transformation of multiplying on the outside by a negative. All right, So in here, h of x is the negative of f of x. This is a reflection over the x-axis. So deflection over the x-axis. All right. Similarly, if I had h of x being equal to f of negative x, this is a reflection over the y-axis. So essentially, what is that really saying? In here, when I multiply it on the outside, since I'm going to reflect over the x-axis, it is essentially a vertical reflection. Whereas this one, since I'm going to reflect over the y-axis, is going to be a horizontal reflection. So let's see what I mean by that. So let's say that I have some curve here on the plane, all right? And I'll do the original curve here in blue. This is my f of x, all right? Now, here in yellow, I'll do the first one. So I have h of x being equal to negative f of x. So we're going to reflect over the x-axis. So that means we're going to use the x-axis here as a mirror of sorts. So essentially, it'll look something like this. All right, let's draw that a little bit better. Not any better at all. One last try. Yeah, I guess. All right, so that is reflecting over the x-axis. Now let's look at what it looks like when we reflect over the y-axis. All right, so over the y-axis is a horizontal reflection. All right, so this is our y-axis, so we're going to reflect this way. So we're going to get something like this. Ooh, my drawing is off right now. Oh, there you go. That's pretty good. So that's our reflection over the y-axis. Now, so in here, again, this is the f of negative x. Down here in yellow, we have negative f of x. Now, it is possible to combine the two, all right? And I'll do that here in orange to combine both. Let's see. This is going to be a reflection over both axes, all right? So something like that. That doesn't look that orange. Let's try a better orange. Is that better? Yeah, I guess that's more orange. So in here, we're going to have, ooh, awful drawing. Yeah, there we go. That's not that bad. This is negative f of negative x. So essentially, we're combining both reflections. First, we're reflecting over the x-axis and then over the y-axis. I said that wrong. Well, I said it right. Reflecting over the x and then over the y, or reflect over the y and then over the x. There we go. So those are all the different kinds of reflections. All right. So in here, let's see where the points actually go to. So the point x comma y would go to here in, well, let's start with the yellow. This is reflecting over the x-axis. This point x comma y ends up going to x comma negative y. All right. Similarly, here in red, that's the same red, yeah. Here in red, it's going to go to negative x comma y. All right. And what I'm talking about is the point x comma y goes to that. And lastly, the point x comma y would go to, in orange here, to negative x comma negative y. All right. So those are all the transformations and how to describe them in terms of the points. So let's see what this looks like. All right. So let's say that I have, if I said let f of x be equal to x squared, sketch the following. So we're going to sketch h of x, which is negative x squared plus 2. All right, so let's see what that's going to look like. First, I want to graph x squared here in blue. And x squared, we know, is just this, right? That's f of x equals x squared. So what would negative x squared plus 2 look like? Well, I'll do this one in yellow. This right here, it's a transformation, right? So that's a reflection. So we're gonna reflect over x-axis, and also we're gonna go up by 2, right? Because of this plus. So reflect over the x-axis, so something like that, but then we need to shift it up by 2. So really we have something like that. That is our h of x. Next one. So D. Let's say that we had something like g of x is the negative of x plus 2 squared minus 1. All right. Now in here, well, what's actually happening here? We have this plus 2 is going to shift everything to the left by 2, right? So this is to the left by 2. Then we're going to reflect over the x-axis, reflect over the x-axis, and then we're going to go down by 1. All right, so that's what we're going to do for this transformation. So to the left by 2, so this is moved to the left by 2. Then we're going to reflect over the x-axis, and then we're also going to move down by 1. So it's actually going to look something like this. All right. So reflected over the, so shifted to the left by 2, reflected over the x-axis, and down by 1. So now let's do another example. Let f of x be equal to the square root of x. Sketch the following. So what letter am I at? E. So we're going to sketch E. We're going to say it's g of x is equal to negative square root of x. All right. So we'll start simple. This one, I'm going to start right here. So here in blue is f of x, is the square root of x function. So there we go. That's f of x. In yellow, let's look at g of x. Negative square root of x. This is our reflection over the x-axis, all right? Because it's happening on the outside of the function. So there we go, something like that. That's g of x. Next one, so E, F. Let's let h of x be equal to negative square root of negative x and then plus 2. So in here, let's see what happens here. What we've got here is a few transformations. We've got first this one, which is a reflection over the y-axis, right? And then we've got this one, which is a reflection over the x-axis. And lastly, we've got this plus 2, which is shifting up by 2. All right, and I'll draw this one in purple here. All right, so reflection over the y-axis, reflection over the y-axis. Then after that, reflection over the x-axis. So from here, reflecting over the x-axis. There we go. And then from there, up by 2 units. Okay, so from here, everything up by 2 units. So something like that. All right, where this value is 2. All right, so there is my h of x. All right. And obviously we can get more creative with this stuff, right, if we really wanted to. Now, so those are so far reflections and shifts. We also have something called vertical and horizontal stretch and shrink. Vertical and horizontal stretch or shrink. Okay. So here we go. Let C be greater than 0. And let f of x be a function. All right, then we get the following. If c is greater than 1, then g of x being equal to c times f of x is a vertical stretch. All right, so we multiply on the outside by a value that's bigger than 1. It's a vertical stretch. Similarly, if c is between 0 and 1, then g of x being equal to c times f of x is a vertical shrink. Now notice I'm keeping this between 0 and 1. The reason is that if c were negative, then that negative would be a reflection of some sort. All right, so we don't have to worry about the case where c is negative. All right, so we can just worry about these two cases. Well, actually, we have two other cases now. If c is bigger than 1, then g of x being equal to f of c times x is a horizontal shrink. All right, when that c on the inside is bigger than 1, it's a horizontal shrink. And remember, the horizontal stuff kind of works backwards from what you expect it to. Similarly, if c is between 0 and 1, then g of x being equal to f of c times x is a horizontal stretch. All right. So what do I mean by that? So let's look at some of these. So in here, let's just get an idea of what one of our curves might look like. If I've got some curve that looks something like this, let's say this is my original curve. All right. In here, this very first one, which I'll do in yellow, if I've got a vertical stretch, that means I'm pulling this upwards, pulling this downwards. So the positive stuff becomes more positive, the negative stuff becomes more negative, but the zeros stay where they're at. And in here, I'm just going to shift this up a little bit because I don't want you to think that it has to go through the origin. Okay, now back to this. So because we're doing a vertical stretch, the zeros stay zeros, the positive stuff becomes more positive, the negative stuff becomes more negative. Here, the positive stuff becomes more positive, and over here, the negative stuff becomes more negative. And what I mean by that is that because it's being stretched, right, it's being stretched vertically, up and down here, the zeros stay there, the positive stuff gets pulled up, the negative stuff gets pulled down. All right, so that's a vertical stretch in that first scenario. Now, let's look at the second scenario here, and we'll do it in purple. We've got a vertical shrink, so that's where c is between 0 and 1. So the zeros will again stay the same, but the negative stuff becomes less negative because now I'm squeezing it down. The positive stuff becomes less positive, the negative stuff becomes less negative, and the positive stuff becomes less positive. All right, so it's all shrink vertically. All right. So this is for the vertical stuff. Let's look at the horizontal stuff. All right. And once again, I'll draw my generic graph here in blue, and I'll do something similar. All right. And now we're doing horizontal stretch and shrink. First, I'll do the first case where c is greater than 1, which happens to be a horizontal shrink. All right, so now we're looking at things in terms of positive and negative in terms of the y. In here, so let me talk about this for a second again. Up here, the x-intercepts stay the same when we're doing a horizontal stretch or shrink. When we're doing a vertical stretch or shrink. Now that we're doing a horizontal stretch or shrink, our y-intercept is going to stay the same. All right, and recall that here I was doing a shrink, right, because c was greater than 1. So over here, essentially, it's going to look something like this. Everything over here is being squeezed this way, and everything over here is being squeezed that way. All right, so something like this. All right. Notice that I'm leaving this relative maximum at the same height. Similarly, this relative minimum at the same height. All right, because that doesn't change. The only thing that's changing here is the x values. The y values should stay at the same kind of heights. So that was the horizontal shrink. So let's look at the horizontal stretch. All right, where C is bigger than 1. This means where C is between 0 and 1. The other one was where C was greater than 1. So this is going to be a horizontal stretch. So again, the x value stays the same. Our max should be at a similarly level max there, our local max, and our local min here, or relative local min, should be at the same height somewhere else. So it should be something like this and like that. All right, this maximum stays at a similar height, this minimum similar height, but it was stretched outwards. All right, so here in purple things were stretched outwards, in yellow things were stretched or shrunk inwards. Similarly, for this one, yellow was stretched upwards and downwards, whereas the purple was stretched or was shrunk, well, upwards and downwards in the opposite way, right? All right. So those are the stretches. Now, how does this look? Let's look at some examples. So sketch. Let me actually rewrite that. Let f of x be equal to x squared. Sketch the following. So I believe I'm a letter J, maybe? That's a good question. G. Let's go to example G. So let's let g of x be equal to 4x squared. All right. So in here, let's see. First, I'm gonna sketch x squared. All right, in blue. So this right here is x squared. Now 4x squared. In here, this is our c. Our c here is bigger than 1, right? So in this case, what I'm gonna do is I'm gonna do a vertical stretch. All right, it's a stretch because our c is bigger than 1. All right, so now in here, what would that look like? That looks something like this. All right. So that right there is g of x. And in blue, or light blue there, we have f of x. So let's say that we have h of x being equal to 1/4 x squared. All right. So h of x being equal to 1/4 x squared. And here our c, and we'll do that in purple. Our c is between 0 and 1. Right, 1/4 is between 0 and 1. So essentially, this is going to be a shrink. All right, and that right there would be h of x. It's a vertical shrink. It's being squeezed downwards. Well, upwards and downwards. All right, now let's do it with another function. Let's say we had let f of x be equal to, let's do the square root of x again. All right, and let in here we're going to say let g of x be equal to let's do 1/5 times the square root of x. All right, so in here, first let's look at f of x. F of x here in blue, looks like that. All right. Now in here, and you know what? I'm gonna change this up a little bit. It's gonna be 1/5 x minus 2. All right. So this right here, this 1/5 on the outside, this is gonna make it a shrink, right? Because c is less than 1, and it's on the outside, so this is vertical shrink. And then this minus 2 over here is going to shift things down. All right. So the vertical shrink essentially makes it do something like this, right? And then shifting it down, well, we got to shift it down, so it's going to look something like this. All right. So maybe I'll make it clearer by leaving the middle step. So this is going to be something like this, right? Being shrunk this way. Oh, hold on. It's a vertical shrink. Oh no. Let's fix all that. That's a good thing I noticed. It's a vertical shrink. Vertical shrink is going downwards. So essentially it's going to look something like that. And then shift down by 2. Well, it's going to look something like this. All right. All right. Next one. J. Let's say that I have h of x being equal to the negative of the square root of 3x plus 2. All right. And this one we're going to see, well, in here, our c is bigger than 1, but it's on the inside, so it's a horizontal shrink. All right, it's a horizontal shrink. All right, and then we have this negative on the outside. This negative on the outside is a reflection over the x-axis, and then this plus 2 is moving upwards by 2. All right, so I'll do the dotted line again. That's the same idea for each step here. So first, the horizontal shrink. The horizontal shrink is being squeezed inwards, right? So we're gonna have something like this. That's the horizontal shrink, right? And then we've got a reflection over the x-axis. Okay, so that's gonna look something like this, right? And then we have upwards by 2 units. So upwards by 2 units. So it'll start here and something like this. Let's make it look better. All right, something like that. All right, that is all kinds of transformations. All right, so we spoke about vertical shifting, horizontal shifting, reflections, as well as stretches and shrinks. All right, that is the end of 1.7.
Wasn't that fun? If you think I made a mistake somewhere, you're probably right. Tell me all about it in the comments. If you feel you learned something from me in this video, hit the like button, hit the subscribe button, but more importantly, share it. Share this video with your classmates. And remember, you don't have to like math in order to be good at it. But you do have to be good at it. I am Jose Orozco. Goodbye.